So here we have the solutions for chapter 9. The answer to the first question, expected value of x, that shall be g, because the expected value of x is denoted by the Greek letter mu. Variance of x, that is e, because the formula for the variance of x is expected value of x minus mu whole square, which is also equal to expected value of x square minus mu square, and it is denoted by sigma square. Standard deviation of x, that is the square root of variance of x, and it is denoted by sigma. The shorthand notation for probability of x equal to x, that is px. So px denotes probability of x equal to x, has 10 times the standard deviation of x. 10x has the 10 times the standard deviation of x because variance of 10x is equal to 10 square variance of x, and that follows from the formula variance of ax plus b is equal to a square variance of x. Here a is 10, in this case a is 10 and b is 0, so standard deviation of 10x is 10 times square root of variance of x, which is the standard deviation of x. Always equals 0. So expected value of x minus 10 is always equal to 0 because this is, here a is equal to 1 and b is equal to negative mu, therefore this is equal to, so we are using the formula expected value of ax plus b is equal to a times expected value of x plus b. So this is equal to a times expected value of x minus mu, or rather 1 times expected value of x minus mu, because a is 1. This is equal to mu minus mu, which is equal to 0. Increases the mean of x by 10. X plus 10 increases the mean of x by 10 because expected value of x plus 10 is expected value of x plus 10, which is mu plus 10. Has standard deviation 1. This has standard deviation 1, this c, and that is because this is equal to x over mu minus 0.04 over mu. Therefore variance of x over mu minus 0.04 over mu is equal to 1 over sigma square variance of x. So standard deviation of that, now this is equal to sigma square over sigma square, which is equal to 1. Hence the standard deviation is also 1, because if the variance is 1, the square root of that is standard deviation. Next question, a cable television provider is planning to change the way it bills its customers. The new billing would depend on the number of computers and televisions that the customer connect to its network. The provider has asked managers to participate in the planning by describing a random variable x that represents the number of connections used by a current customer and random variable y that represents the number of connections used by a customer after the changing of billing. A customer must have at least one connection. All customers must have one connection. First question, the function defined as probability, so it should be probability of 1 is equal to 1/2, probability of 2 is equal to 1/4, probability of 3 equal to 1/8, 4 equal to 1/8, x equal to 0, x equal to 0 otherwise is a probability distribution that can be used to model x. So here x is the number of connections used by a current customer, and we are asked if this 1, 2, 3, 4, 1/2, 1/4, 1/8, 1/8 if this is a proper probability model. The answer is yes, it is a proper probability model, because all these numbers are greater than 0 and they sum up to 1. So you have 1/2 plus 1/4 plus 1/8 plus 1/8, which is equal to 1/4 1/2 plus 1/4 plus 1/4, which is equal to 1. So hence it is a proper probability model. The function defined as this is can be used to model x. No, it cannot be used to model x, because the distribution is x takes the values 1, 2, 3, 4 with probabilities 1/2, 1/4, 1/2, -1/4. So here they add up to 1, but this number here is less than 1, less than 0, so it cannot be a valid probability model. In the new style of billing, increases the average of connections used by customers, then expected value of x is greater than expected value of y. That is false, because it says the new style of billing increases the average number of connections used by the customers. So y is the connections used by the customers after the change of billing. The number of connections after change of billing, and x is the number of connections before the change of billing. If the expected value were to increase, then expected value of y would be greater than expected value of x. If the customer has 1 to 10 possible connections in the current step, then 1 is lesser than or equals expected value of x lesser than or equals 10. True or false? So x lies between 0 and 1. Therefore, expected value of x shall lie between 1 and 10. So if x lies between a and b, then expected value of x shall also lie between a and b. Okay. The mean expected value of y must be an integer, because its random variable can be any integer, can only be an integer. The answer is false, because even if the random variable takes only integer values, its expected value does not have to be an integer value. If the cable network counts the number of connections used by 100 customers, then the average count of these customers is same as expected value of x. That is untrue, because these 100 this average count depends on these 100 customers, not based on the distribution. This expected value of x depends on the distribution. So for example, if I have a random variable, let's say x is the number of h's appearing when you toss a coin once. So x takes the values 0, 1 with probability 1/2, 1/2. Now expected value of x is what? 1/2. Now if I toss the coin 20 times, let's say I have 1, 0, 1, 1, 0, 0. Now would the average of these 20 be equal to 1/2? No. But this average is just based on these 20 observations. They will not be equal to 1/2. So based on a similar argument, we can say the average of these 100 individuals will not be equal to the population mean, that is the expected value of x, which has been found from the probability distribution. So here we have another problem. An insurance company uses a random variable x to model the cost of an accident incurred by a female driver who is 20 to 30 years. A second random variable y models the cost of an accident by a male driver in the same range of ages. Both random variables are measured in dollars. If the mean of y is 3200 and the variance of y, then the variance of y must be larger than 3200. If expected value of x is equal, so the answer to the first, the answer is false, because if the mean and variance are not directly related and you cannot predict one from the another. So if the mean is 3200, that you cannot say anything about the variance. If expected value of y is 2300, then probability of x lesser than or equals 2300 is 1/2. That is also false. Merely based on the expected value, we cannot predict this probability. We need the distribution to answer this question. If the unit of mean and the standard deviation, the units of mean and the standard deviation in dollars, that is true. The units of expected value and standard deviation are same as the unit of x. If an insurance policy limits the coverages of an accident to 500,000, then both expected value of x and expected value of y must be less than 500,000. So that is also true. If x is less than 500,000, then expected value of x is less than 500,000. If y is less than 500,000, then expected value of y is less than 500,000. So this one, the question 18 essentially says if x, and this is similar to what we had done earlier, this problem. If x lies between a and b, then expected value of x also lies between a and b. So number 19, if the cost associated with the accident increases by 5%, then the mean and the standard deviation, then the mean of the random variable also increases by 5%. Our initial cost associated with the accident was x1. Now the cost associated with the accident in second year is, there is a 5% increase, so it shall be 1.05 times x1. So expected value of x2 is 1.05 times x1. So the 19 is true. The cost associated with the standard deviation also increases by 5%. That is true because my initial random variable was y1, my y2 is 1.05 times y1. So standard deviation of y2 is standard deviation of 1.05 y1, which is equal to 1.05 standard deviation of y1. Okay, so 19 is true and 20 is also true. Both of them are true. So maybe I should write here true and this also true.